Hello friends, myself Professor Amit Shirsagar, and in this video tutorial we are going to learn practical about subject embedded and real-time operating system. Okay, so in this video we are going to learn practical on program for 7-segment interfacing using Cortex microcontroller. Okay, so before starting the coding part, we will learn a few things or a few theory part regarding this particular practical. So what is our aim of the experiment is we have to write a program to display digits 00 to 99 on 7-segment display interface with the Cortex microcontroller, that is nothing but the LPC1768. So to perform this practical, what we required is we require a board with the Cortex M3, that is LPC1768 development board, FRC connector, power supply, adapter, and the software required is Kill Microvision 4 and Flash Magic. Okay, so I think all of you are aware about what are the features of this ARM Cortex controller. So you can take an overview of the features of your ARM Cortex controller. So this is one of the popular microcontroller among the ARM microcontroller family. Okay, so having a number of functionalities provided so that it can become a powerful 16-bit microcontroller. Okay, so regarding the interfacing, we will learn the diagram. Okay, so let us focus on how the interfacing of LPC1768 or Cortex microcontroller is done with the 7-segment display. Okay, so here we are using the two 7-segment modules. Okay, because we are going to display 00 to 99. Okay, so for single digit we require one 7-segment, and for 2 digit we require the 2 7-segment. Okay, now the enable pin of these two 7-segment has been connected to the port 1. Okay, and the remaining pins A, B, C, D, E, F, G, all these pins are connected to the port 0 of your Cortex controller. Okay, so if I want to display 00, right, so at one time one segment will be enabled and the particular 7-segment code will be loaded on the particular, or this 7-segment code will be given through the port to this particular segment. Okay, so each time we have to enable two 7-segment one by one. Okay, suppose I want to display 23. Okay, so if I want to display 23, I have to separate the 2 digit. 2 and 3 are separate digit, right? So when I say divide, when I make divide by 10, then I will get the 2. So I have to give this code for 2 on this 7-segment. Okay, and when I perform the operation 23 modulo 10, 23 modulo 10, then the 3 will be separated and the code for 3 has to be sent to this particular segment. Okay, so like that the program has been done so that we can display digits from 00 to 99. Okay, now what codes we have to send, we have to just take an overview. Already you are aware about how we can display the 7-segment. Okay, so the segments are A, B, C, D, E, F, G. Okay, so according to the digit we have to display, we have to turn on the different segment. So on means 1 and off means 0. Okay, so according to that the different hex code are required. Okay, so to display digit 0 we require hex code of 7E. If I want to display 1, I have to apply the code 30. That is nothing but the hex code for the required to for the 7 segment module. Okay, so all you must remember that whenever you have to display any digit, we have to follow this table for hex code. Now in our program what we have done is we have stored these all hex code for the digits in the particular character array. Okay, and that array we are accessing every time for displaying the particular digit on 7 segment. Okay, so without wasting time we will see how we can develop the code using the Kill Microvision. So here what I am doing is I have to open the Kill Microvision 4 software, then click on project, new project. Okay, so here I am going to create a folder on the desktop. Okay, so here I will create a project on desktop for like segment. Okay, so I write segment folder. Okay, now selected this folder. Okay, so I write here segment. Okay, so I will give the name segment 2 digit. Okay, segment 2 digit. Just I am giving the name to the particular project. Okay, so here you have to select the device. So I have to write LPC 1768. Okay, so you have to select this device, click on OK. Then it will ask copy startup code. Okay, so here you must click on yes. Okay, we require this startup file. Okay, if you don't add the startup file, your code is not going to be run. Now I have to write the program, so here I am clicking on the new file. Okay, so already I have the code. So what I will do is I will copy this code. Okay, then I paste this code in this particular window. Okay, this is for my convenience. I am copying the code from the directly from the file. Okay, so now we have to save this particular file. So type Control S. Okay, so save the file. I am saving the file as a in small letter. I am saving the file main.c. So you have to save the file with the .c extension. Okay, do not make mistake here. Click on OK. Now you must have to add this file. So right click on source group 1, then add existing file. Okay, click on main, add and close. Now this is not just sufficient, we have to add 3 more files. Okay, so for convenience what I've done is I have taken this file, Cortex file. So we have to add these 3 files. Okay, core underscore cm3 lpc 1768 underscore includes, and then system underscore 17xx. Okay, so these 3 files we have to include in our project. Okay, so I once again open the this particular project, right click on this, add existing file. Okay, so what I have done is I have kept all this file on the desktop folder called Cortex files. Okay, so wherever you have kept this file, you have to select that folder, particular folder. Okay, so here I am able to see only two files. So here click on files of type, then select all files. Okay, now you can see all files. Okay, add these three files, then close. Okay, now one more thing is required. You have to right click on this particular option for target one, then click on output tab. Here click on create hex file, then click on OK. Okay, then build the code. Okay, so what error is occurred here? Okay, so target not created. We will rebuild the code again. Okay, here it is showing some error. Again we'll try out this one. Okay, so one more thing is required. Now this error is occurred due to the include path. So right click on target one, here click on C tab. Okay, then click on this include paths, then new insert. Again here we have to click on this dot. Okay, now again on the desktop we have folder Cortex file. Okay, so Cortex file, yes. Okay, one more time we will try out this one. Okay, delete this file. Okay, so include path is, yes, on the desktop we have Cortex file. Okay, just hold on, this one, yes, Cortex files. Okay, so now we will see we have included the now we will rebuild the code again. Okay, now so the problem has been solved. We have not included the file, included the path, that's why the error was occurred. So this is how we can debug the code. So I think all of you have understood what step we have carried out in order to build this particular project. Okay, now we will understand the code for this particular. So let us understand how the configuration is done. So segment A, so segment pins. Okay, so A is connected to port 0.0, A, B, C, D, E. So all these segment pins for both the 7 segment are connected to the port 0, pin number 0 to pin number 7, pin number 6. Okay, then for segment 1 to for segment 1 selection, port 0 pin number 8, and for segment 2 port 0 pin number 9 we have connected. Okay, so let us understand the code. So we have to include this header file lpc1768 underscore includes.h. Okay, now to enable the segment 1, we are defining the 1 at 8 position. Okay, then for segment 2, to enable the segment 2, we have defined this particular segment 2 constant. Okay, now for 0 to 9, we are defining this hex code to the constant variable. Okay, so all these hex codes are assigned to the different constant variable, or we have created the constant for the different digit. Okay, so now after that delay code is given, that is for giving the delay of 1 millisecond. In the main program, what we have done, okay, so segment data, we have created a character array consisting of 10 values. Okay, so all those hex codes are stored in this particular array. Okay, so this is we have done for our convenience, because every time we cannot remember the hex code value, or we cannot use the hex code value in the program. That may look like a complicated. Okay, so after that, for looping, we are using the variable I and j. Okay, then pin select register is configured to 0, so that we can use the pin as a output. Then after that, this pin select register, we are assigned value 00, because we are using the port 0 as a GPIO pin. Okay, then after that, we have used the IODIR register. Okay, FIODIR. Okay, FIODIR is to configure the port 0 pin as a output pin. Okay, and initial condition we have set is all pins, segment pins are off. Okay, so here we have we are connecting this 7 segment in a common anode connection. That's why we have to send 1 to all the connected pins, that so that the 7 segment display will be off. Then in while 1, okay, while 1 means the continuous or unending loop. So we have to display the digit 0 to 99, 00 to 99. Okay, so that's why we have created the loop I equal to 0, I less than 100. Okay, less than 100 means it will not go to the 100 value, it will be 0 to 99. Okay, the value of I will be incremented. Then j equal to 0, j less than 30, j plus plus. Okay, so we are now giving the 7 segment value. Okay, now we have to select for example, if 00 is there, so or any digit, you take any digit, 23 for example, we take 23. So if I want to display 23, okay, so first of all what I will do is I will display 2 and then I will display 3 on the 2 different segment. Now to display 2, I have to select the first segment. Okay, so using this 2 instruction, we are selecting the segment 1. Okay, now how to separate this 2? For that purpose, I divide by 10. Okay, I divide by 10. Okay, if you make 23 divided by 10, the answer will be 2. Okay, so 2 will be separated, and when you access the second element of segment data array, the code for 2 will be accessed, and the same code will be applied to the port 0. Okay, then delay is applied of 20 millisecond. Okay, then after that IO clear. Okay, now we want to display 3. For example, we want to display 3. So if we want to display 3, we have to select the second segment, and for that purpose we have to use the IO set and IO clear instruction. So these two instructions are given for selecting the second segment. Okay, then to extract 3, okay, suppose number is 23, and if I want to extract the 3, then the operation will be 23 modulo 10. When you perform 23 modulo 10, then 3 will be extracted. Okay, so modulo operation gives the remainder. Okay, and this is how we get the 3 will be separated, and the code for 3 will be searched in the segment data array. Okay, and that code will be applied to the port 0. Okay, and this is how 2 and 3 will be displayed. Okay, then in the next cycle the value of I will be incremented in this particular loop, I equal to 0, I less than 100, I plus plus. So every time the value of I will be incremented, and this particular digit code will be sent to the segment 1 and segment 2. Okay, so let us understand how we can debug the code. For debugging the code, we have to click on build code. Okay, so 0 error and 0 warning. Okay, so in this case what is going to happen, we have created the folder segment. Okay, so under that the hex file will be created. So you can see with the name of project the hex file will be selected. Okay, we have to select this hex file using Flash Magic software. You have to burn the hex file on the particular Cortex kit. Okay, and by that by making connection you can be able to view the digits from 00 to 99. Okay, so we have done 90% of this particular practical part. Only part which is remaining is that is applying this code on the actual microcontroller board. Okay, so with this I finish my session. Here I have explained all the instruction part related with this particular practical. Okay, so if you have any kind of suggestion or any doubt, you can mail me at shirsagar.an@gmail.com, or you can call me at 9527-299-300. Okay, so thank you very much for patient listening.